Okay, now we are going to run a simulation on PhET to illustrate sound waves and their constructive and destructive interference. What we can see here is that there's two speakers, and they're both giving off the same sound wave. In this area, it's just this one single sound wave, so there's no constructive or destructive interference happening. But here is where the two sound waves start to overlap. In this area, we see areas where the two bright areas of the sound wave overlap, the constructive areas, and they cause a brighter white part. And these dark areas have the same thing, where the hills are matching up, causing a louder sound wave. Now, in these other areas, as you can kind of see, like between them, if you look closely, you can see a light gray region, which is the same color as this background. In that area, there's destructive interference, meaning that the hills match up with holes, or the top of the wavelength matches up with the bottom of the wavelength and cancels each other out. So if you're standing in that area, you won't hear any noise. Now, we can move this guy around, and for instance, if he's standing here, he's standing in the sound waves, and the light in the dark, so he's going to be hearing sounds. If he's standing somewhere like right here, where while they are still overlapping, the dark and the light match up, he's going to be hearing. Now, if we move him down just a little bit into that tiny gray area right there where there's destructive interference, we'll actually realize that he won't be hearing anything at all because the sounds have canceled out. In a future lesson, we will discuss why these things are happening, but right now we were just looking at the way that the waves lined up. In our next video, we're going to explain how this happens mathematically and look at some examples of problems.